Welcome. This is the last part of the solution video. In this part, we are going to discuss problem 15 through problem 20. Problem 15. A bottle is partially filled with water and the height of the water is 15. And if we make the bottom upside down, then the empty part is 5. So what we can observe is that the green region has the same volume as the red one. Okay, so since the green region is the shape of a cylinder of height 5, it is 1/3 of the cylinder of 15. So 5 to 15. So therefore, the bottle here is 3/4 full. Since the total volume of the bottle is 400, then the total volume of the water is 3/4 times 400, which is 300. And the answer is D. Problem 16. We use the hint that we assume the original speed of the rig was 1. So suppose Mike's speed is x. If the rig takes speed up 3 times, and he will be catching up Mike with 6 hours. So that means 3 minus x. We assume Mike's speed is 3. So 3 minus x would be their relative speed. And in 6 hours, the distance would be 6 times 3 minus x. That would be the same as if the rig speed up 4 times, and he will catch up with Mike in 3 hours. So that will be 3 times 4 minus x. And this number is equal to L, which is the distance between the rig and the Mike, so that the rig can make up that distance to catch up with Mike. So if we solve the first equation, we would get 18 minus 6x equals 12 minus 3x. So therefore, 6 would be equal to 3x, and x is equal to 2. When x is equal to 2, L is equal to 6 times 3 minus 2, which is 6. So the distance between the rig and the Mike originally was 6. The answer is D. Problem 17. A frog starts from the center of the circle and jump exactly 5 times, and you would like it to be back. So how many different ways? So first, we would realize that the first jump must be in one of these 4 circles. 1, 2, 3, 4. So by the symmetry of this picture, we would like to see, we would like just to pick up 1 point here. And in how many ways that if a frog starting from here and in 3 steps, it will be back. So altogether, there will be 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. There are 4 ways to be back here. So totally there are 4 ways. But there's another way to jump 5 steps to be back. 1, 2, 3, 4, 5. And you can go back. So there are another 2 ways to do. Totally, the first jump would be one of the 4. So totally it will be multiplied by 4. So it's 6 times 4, which equal to 26. So the correct answer is B. Problem 18. The sum of the 4 distinct positive integers is 630. So what is the largest possible greatest common divisor of these 4 numbers? So let's use inequalities to see what's the maximal possible greatest common divisor. So suppose we have A1, A2, A3, A4 to be the 4 distinct positive numbers. So P is called the GCD of the 4. Okay, so the greatest possible common divisors. So therefore, A1 plus A2 plus A3 plus A4 is equal to 630. And divided by P on both sides is equal to 630 by P. So since P is the greatest common divisor, so this right-hand side would be an integer. So this would be an integer. Each term of the left-hand side must be integer as well, and they must be distinct integer. So therefore, the minimum of them would be at least like 1 plus 2 plus 3 plus 4 because they have to be distinct. So that totally would be 10. So we had the inequality 10 less than equal to 630 over P. So that means P is less than equal to 63. So by this argument, we know that the largest possible greatest common divisor at most would be 63. So let's check 63 is actually, it could happen. Well, that's simple because we take A1 equal to 63, A2 equal to 2 times 63, A3 equals 3 times 63, and the A4 is 4 times 63. So they add up to be 630. So therefore, the maximum possible greatest common divisor for this problem would be 63, and that would be the answer. Problem 19. That's a typical problem in area. So there's one problem that we probably need to remember. So if we have a trapezoid and suppose two diagonal just divide the quadrilateral into 4 pieces. Suppose the area of the top triangle is S1 and the bottom triangle would be S2. So there are 2 results. First, these 2 areas are the same. And S is actually equal to square root S1, S2. Why that is the case? The reason is that if we mark the trapezoid as ABCD, then since AD is parallel to BC, we must have triangle ABC has the same area as triangle DBC. And if subtract these areas by S2 from both of them, we would get, suppose this is P, so we would get area of ABP, triangle ABP would be the area of triangle ABC minus the area of triangle PBC. That would be equal to the area of triangle DBC minus the area of triangle PBC. And that would be equal to triangle PDC, the area. We also have that S divided by S2 is AP over PC, while S1 divided by S is also AP over PC. So if we equalize this, we would get S equal to square root S1, S2. So using this result, we can solve the problem. If we draw a line from E to D, we would realize that the area of triangle EDF would be equal to square root 2 times 8, which is equal to 4. So therefore, the area of triangle DEB would be equal to 2 plus 4, that's equal to 6. And the area of the triangle DAE is, by definition, 6 minus 4, that's going to be equal to 2. So AE over EB would be equal to 2 over 6, that's equal to 1 over 3. So BE over AE, that will be equal to 3. So that is the answer. Problem 20. In order to solve this problem, we need to make the following observation. We let K be the second largest divisor of n. And since k divides n, we can write n as k times p. The first observation is p has to be a prime number. So p is a prime number. Why? Because if it's not the case, then we can write p as p equals p1 times p2. And if we assume that p is not a prime number, then both p1 and p2 are not equal to 1. And because of that, we can rewrite n as k times p1 times p2. So first, since p2 is not equal to 1, k times p1 is strictly less than n. And second, since p1 is not equal to 1, then k times p1 is strictly bigger than k. So we have the following inequality: k p1 is strictly less than n and strictly less than k. Okay, so since k p1 is strictly less than n, k p1 shouldn't be the largest divisor of n, which is n itself. And since k p1 is strictly bigger than k, well, it has to be the largest divisor of n, because by our assumption, k is the second largest one. So that would give us a contradiction. And then we proved that p is a prime number. And there's one more thing we have to observe, is that k has to be bigger than or equal to p, obviously, because otherwise you can use p instead of k. All right, so now let's write kn, which is by definition n plus k. And since n is kp, we can write it as kp plus k, and if we can factor out k, we will get k times p plus 1. Assume that this is equal to 100. So the conclusion is p plus 1 must divide 100. Or in other words, p plus 1 has to be a divisor of 100. Since 100 is equal to 2 squared times 5 squared, we know that the number of divisors of 100 is 9. 2 plus 1 times 2 plus 1 is equal to 9. And we can list all of the divisors of 100. So 1 is the divisor, 2, and 4. And if we multiply them by 5, we get 5, 10, and 20. And if we multiply them by 5 again, we get 25, 50, and 100. So these are all the divisors for 100. So what should p plus 1 be equal to? Well, first, this is not true because 100 minus 1 is not a prime number. This is not 49, 24. This is 9. This is 4. And these are not. So the only choice would be either p plus 1 equals 4, and in this case, p equals 3, and so k would be equal to 25, and the n has to be equal to 75. So we can double check. K 75 is equal to 75 plus its second largest divisor, 25. That's equal to 100. That gives us one solution. And the p plus 1 equals 20, p equals 19. Well, 19 is a prime number, but it does not satisfy k is greater than or equal to p, because if p were 19, then k would be equal to 4. 4 is not bigger than or equal to 19, so this is not a solution. Okay, so the conclusion is that the equation kn equals 100 has only one solution, and the correct answer is B.